Hello everyone. Let us continue the third part of today's class. Okay, in the beginning, let us look at new announcements. Okay, the first new announcement is the slides of Chapter 4 has been updated. Version 2022-0514B. Hello everyone, I have uploaded the latest version of the slides of Chapter 4 to the eCourse2 website. The location and the file name are eCourse2 website, multiple input, multiple output techniques for wireless communications, course content, slides, Chapter 4, slides 2022-0514B.pptx. Best regards, Wei Zhen. Okay, the next new announcement is the handout of Chapter 4 has been updated. Version 2022-0514B. Hello everyone. I have uploaded the latest version of the handout of Chapter 4 to the eCourse2 website. Excuse me. The location and the file name are eCourse2 website, multiple input, multiple output techniques for wireless communications, course content, handouts, Chapter 4. Excuse me. Handout 2022-0514B.pdf. Best regards, Wei Zhen. Okay, please open the slides of Chapter 4 and please turn to page 9. Okay, we are talking about the phenomenology of multipath channels. In any wireless communications path between a transmitter and a receiver, signals arrive at the receiver through various propagation mechanisms. In general, RF, that is radio frequency energy, propagates between two points in one of two ways, directly or indirectly. Direct propagation refers to transmission of RF energy along a direct path between the transmitter and the receiver that does not involve any reflections. What are reflections? Let us see the handout. Page 10, Problem 1. What are reflections? Solution. Reflection is the change in direction of a wavefront. We will introduce what is wavefront later in problem 2. At an interface between two different media so that the wavefront returns into the medium from which it originated. Do you know the word medium and the media? Media is the plural form of the word medium. Common examples include the reflection of light, sound, and water waves. The law of reflection says that for specular reflection, the angle at which the wave is incident on the surface equals the angle at which it is reflected. Okay, mirrors exhibit specular reflection. Please see figure 4. Okay, let us see figure 4. Okay. So figure 4 is the reflection of Mount Hood in Mirror Lake. Okay, please see this figure. Okay, this is a mountain, and this is the lake, and this is the reflection image of the mountain. Okay. Okay, let us go back to here. Problem 2. What is wavefront? Okay, solution. In physics, the wavefront of a time-varying wave field is the set locus of all points having the same phase. Okay. The term is generally meaningful only for fields that, at each point, vary sinusoidally in time with a single temporal frequency. Otherwise, the phase is not well defined. Okay, please see figure 5. Okay. Okay, this is figure 5. The wavefronts of a plane wave are planes. Okay, so this is a plane wave, and the red rectangular are the wavefronts of the plane wave, and this arrow denotes the direction of the moving direction of the plane wave. Okay, let us go back to the slides. Okay, reflections, scattering. Okay, we have explained what is scattering, okay, earlier in today's class. Okay, ducting, or what is ducting? Let us look at the handout. Okay, problem 3. What is a ducting? Okay, solution. In telecommunications, an atmospheric duct is a horizontal layer in the lower atmosphere in which the vertical refractive index gradients are such that radio signals and light rays are guided or ducted, tend to follow the curvature of the Earth, and experience less attenuation in the ducts than they would if the ducts were not present. Okay, please see figure 6. Okay, figure 6 shows the Fata Morgana of Farallon Islands with clearly seen duct. Okay, you can see that there are 3 parts in this photograph. Okay, the region above this line is the sky, and the region below this line is the sea. Okay, and the region between this line and this line is the Fata Morgana. Okay, so what is the Chinese meaning of Fata Morgana? Okay, let me show you. Okay, it is 海市蜃楼. Okay, let us go back to the handout. Okay, problem 4. What is the refractive index? Okay. Solution. In optics, the refractive index, ARCA, refraction index of an optical medium is a dimensionless number that gives the indication of the light bending ability of that medium. Okay, please see figure 7. Okay, let us see figure 7. Okay, so figure 7 shows a ray of light being refracted in a plastic block. Okay, you can see that the light here in the air, and when it encounters a different medium, that is a plastic block, it will deviate away from the original direction. Okay, so it is in the path, okay, here in the plastic block, and then out of the plastic block and return to the air again. The light is in this path. Okay, you can see that this line and this line, okay, are parallel. Okay, let us go back to the first time of figure 7. Okay, so let us go back to the slides. Okay, ducting or diffractive bending. Okay, what is diffractive bending? Okay, let us look at the handout. Okay, let us look at problem 5. What is diffractive bending? Solution: diffraction refers to various phenomena that occur when a wave encounters an obstacle or opening. It is defined as the interference or bending of waves around the corners of an obstacle or through an aperture into the region of geometrical shadow of the obstacle. Aperture. The diffracting object or aperture effectively becomes a secondary source of the propagating wave. Italian scientist Francesco Maria Grimaldi coined the word diffraction and was the first to record accurate observations of the phenomena in 1660. Please see figure 8. Okay, figure 8 is a diffraction pattern of a red laser beam projected onto a plate after passing through a small circular aperture in another plate. Okay, like this. Okay, I need to make it smaller. Okay, so good. Okay, so it is a diffraction pattern. Okay, let us go to the first time of figure 8. Okay, here. Okay, let us go back to the slides. Okay, direct propagation is called free space propagation and is said to undergo free space attenuation. Indirect propagation, in contrast, involves any one or a combination of the following: reflection, diffraction, scattering, or refraction. Okay, what is refraction? Let us go to the handout. Okay, page 11, problem 1. What is refraction? Solution: in physics, refraction is the redirection of a wave as it passes from one medium to another. Please see figure 7. Okay. So actually, we have seen this figure earlier. Okay, figure 7, a ray of light being refracted in a plastic block. Okay, like this, in the air, and in the plastic block, and in the air. Okay. Okay, let us go back to the slides. Because of these mechanisms, indirect propagation enables radio frequency energy to propagate over multiple paths between the transmitter and the receiver, giving rise to multi-path propagation. It follows that multi-path propagation is capable of supporting communication over non-line of sight (NLOS) paths. Okay, we have introduced what is non-line of sight in the handout of chapter 1. If you forget, please review it. Okay, next. Although most non-line of sight paths involve some amount of multipaths, multipaths can also occur on line of sight (LOS) paths. Okay, we have also introduced what is a line of sight in the handout of chapter 1. Okay, if you forget, please review it. And this has important implications for the utility of MIMO when the transmitter and the receiver are within line of sight of each other. Okay, figure 4.1 depicts the various propagation components for a general wireless channel. Okay, let us go to figure 4.1. Okay, this figure. So figure 4.1 shows the propagation mechanisms in a wireless channel. Okay, here is the transmitter and here is the receiver. Okay, so there are 3 components. Okay, departure from the transmitter. The first one is the refracted component. Okay, you can see that the path of this component is not a straight line. Okay, and to receiver. And the second component is the direct path or the direct component. And the third component is the diffracted component. Okay, when it pass the edge of an object, okay, it will deviate, okay, away from its original path. Okay, so it will have an angle here, okay, and go to here. And when it encounter an obstacle, it will be reflected, okay, and reflected again, and go to the receiver. Okay, so this is the reflected component. And the scattering components come from, okay, all possible directions to the receiver. Okay, the effect of the various propagation mechanisms can be seen by measuring received power versus distance from a transmitter, as illustrated notionally in figure 4.2. Okay, what is notionally? Let us see the handout. Okay. Page 13, problem 1. What is notionally? Okay, solution. Notionally is the adverb of notional. The word notional means existing only as an idea, not as something real. Okay, let us go back to the slides. Okay, and let us go to figure 4.2. Okay, figure 4.2 is the notional illustration of the dependence of received power on distance between a transmitter and a receiver over a multi-path channel. Okay, the x-axis is the distance, and the y-axis is the received power in dBm. Okay, and you can see that there are 3 curves in this figure. Okay, we will introduce what is the meaning of these 3 curves later. So first, let us look at dBm. Okay, what is the meaning of dBm? Okay, please look at the handout. Page 15, problem 1. What is dBm? Okay, solution. dBm, sometimes dBmW or decibel milliwatts, is unit of level used to indicate that a power ratio is expressed in decibels. Okay, that is dB. With reference to 1 milliwatt, okay, which is abbreviated as a small m and a capital W. To express an arbitrary power P in milliwatt, x in dBm, or vice versa, the following equivalent expressions may be used. Okay, so first, x is equal to 10 times log 10 of P over 1 milliwatt, and P is equal to 1 milliwatt times 10 to the power of x over 10. Okay, let us go back to the slides. Okay. Let me see. Okay. Here. Okay, in this figure, okay, that is figure 4.2. The wiggly curve depicts the received signal. Okay, what is the wiggly curve? Okay, let us see the handout. Okay, page 16, problem 1. What is wiggly? Solution: shaped like a line with many curves. Okay. So let us go back to the slides. Okay. So in this figure, okay, that is figure 4.2, the wiggly curve depicts the received signal. Okay, actually, strictly speaking, it should be the received power of the received signal. Okay, and here is the wiggly curve. Okay, although there is only one received signal, we observe that there are 3 different propagation components, each with its own characteristic scale. Okay, the feature with the largest scale in this plot is the linear trend towards lower received power when the power and distance are plotted in dB. Okay. So, okay, you can know that here is a linear, here is a straight line here. And please note that the power and distance are plotted in dB. Okay, So the distance is in dB. Okay, it is 25 minutes. Okay, see you next time. Goodbye.